I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll explore sequence and series using sigma notation. The question here is, write first 5 terms, then evaluate the summation. So the question is to sum the series 3n plus 5 where n changes from 1 to 100. We are going to have different approaches to solve this particular question, and that makes it interesting and useful. The idea is to understand strategies to solve questions so that in our test we can perform much better. So one of our strategies is going to be to write the first 5 terms and then evaluate this expression, and the other is going to be to split this into 2 different series, right? So we have here the second part to this, that is separate the sum in 2 sums, then evaluate the summation. Clear? Well, related formula are also given to you. So these are known to you. I'd like you to pause the video, answer this particular question. Basically, you need to find the sum of this particular series using 2 different ways. Well, in case you want to learn from me, you can always send an email on the address given. Our students are doing extremely well. I'm glad to share with you that Akshat has scored highest marks and is getting awards and scholarships.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
Now, let's look into the solution. So first approach, as I was saying, is to write first few terms and then do the summation. 3n plus 5 is a linear expression, right? So in such linear expressions, what do you expect? You expect arithmetic series, correct? So when you look at a question, you kind of understand that this is a linear expression. And so that is going to leave us with arithmetic series. Now arithmetic series are easy to work out. And if you know the first term, the last term, you can use the summation formula, which is given here. So you need to know number of terms, first term and the last term in arithmetic series to find the sum, and that is going to be our approach, right? So we can actually expand this and rewrite all the terms. So if I substitute n equals to 1, what do I get? I get 3 times 1 plus 5. So that becomes the first term, right? And the second will be what? Well, second will be substituting n as 2, 3 times 2 plus 5, and so on. The last will be what? The last will be by substituting n equals to 100, right? So 3 times 100 plus 5. So these are different terms. 3 plus 5 is 8, so we get this, and then we have 6 plus 5 is 11. So as you can see, it is increasing by 3, right, as expected. So the common difference is 3. And the last term will be 305. So from here, you can see that A, the first term, or let me write T1, since in the formula I have written T1 and Tn. The first term is 8. Common difference is 3. The last term, which is the 100th term, will be 305. And number of terms n, as you know, is 100, since we are going from 1 to 100, right? So clearly we have the sum of the series, and therefore we could write the summation n equals to 1 to 100 for 3n plus 5 as equal to 8 plus 11 plus, we can add 3 more, right, and get 14, correct, till the last term, which is 305. And this sum will be number of terms n, so we are using this particular formula right here. Number of terms being 100, first term being 8, plus the last term 305 divided by 2. Is that clear to you? Correct? So that is how we can find the sum of this particular series. So we have 305 plus 8, which is 313 times 100 divided by 2. So that gives you 15,650. Is that clear to you, right? So you can calculate the answer. Perfect. So that is how we get our solution to the given question. So what we did here is that we recognize that this series belongs to arithmetic sequence. So addition of this will be arithmetic series formula, which is n times first term plus last term divided by 2. We expanded the series to find the terms, the common difference, first and the last term, substituted them in the formula, and got our answer. Correct? Now let's look into the second strategy. So I hope this is absolutely clear. So now we'll use the summation notation and its properties. As you can see, we can now write down the summation, which is from n1 to 100 for each one of them separately. So we have n equals to 1 to 100 for the two terms, which are 3n plus the constant term, which is 1 to 100 for 5. Correct? Now the first term, 3 is a constant, n changes. We could write 3 here, and we can write the summation of n terms and natural numbers moving from 1 to 100. Correct? So this is sum of first 100 natural numbers. You get the idea? Plus, we have here a constant term 5, which is going to be added 100 times, right? Clear? So the constant term n, natural number sum, is given by n times n plus 1 over 2, which you can also derive from the arithmetic sequence where the first term is 1, right? Okay, so now we can write down the sum. So the first term will be 3 times the sum of first n numbers, which is n times n plus 1 over 2, and we are writing the formula, right? Plus 5 times n, right? 5 times n. Now in this case, n is 100, right? Well, we are going up to 100. Since n equals to 100, we can write this as 3 times 100 times 101 divided by 2, plus this 5 is going to come 100 times, right? So it will be 500. And that gives you 3 times 50 times 101 plus 500, correct? And that gives you the answer, which you can again calculate. So we have 3 times 50 times 100 plus 500. And that is again same answer, which is 15,650, right? Make sense? So that becomes our second method of solving the same question. So let us summarize what we learned in solving such questions. So basically, when you look at this type of a question, you could follow one of the two strategies as we discussed just now. First one is write the terms and write it as arithmetic series, and the other one as sum of two series, right? And then add them up, right? So that is how you'll get the answer. So I hope this strategy is absolutely clear. Feel free to write your comments and share your views. In case you like and subscribe to my videos, that'd be great. And if you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.